A little dim today because we're talking about light, and we need to be able to see what's happening on the table, and some of it's kind of dim. We're going to talk about light not as a wave. In Chapter 17, we looked at the wave model of light. In Chapter 18, we're going to speak about light as rays. Now, a ray is really a mathematical construct, but we're going to talk about light as traveling in straight lines. It travels in tight beams, like this beam from the laser pointer. That is a great representation of how we'll visualize a ray of light. And right here, I have a ray box on the table that makes 3 rays of light that come out here. And again, it's just a mathematical construct, but it helps us trace the path of the light. The light starts here, goes this way. And now we're going to insert something into the path. What we'll insert is a mirror. And you can see that the rays of light bounce off the mirror. They come in, they hit the mirror, and they come off. Now we're going to characterize this reflection, and we'll do it like this. First off, I'm going to draw a line that represents the surface of the mirror. So I'll use my pencil, and I'll sketch a line right here. Then I'm going to pick the middle ray. I'm going to pick the middle ray, and I'm going to draw a line that represents the incoming ray right here. Okay, so here's the ray that comes in. Then I'll draw a line that represents the ray that comes out, which is right here. That's my outgoing ray. And now I'll do this. I'm going to go ahead and take this line from the mirror, and I'm going to draw a perpendicular to it. And I'll use the mirror to help me do that. And we call that the perpendicular or the normal. So I'll draw a normal to the surface, and the normal means it's perpendicular. And then I'll characterize what happens at the surface by 2 angles. First off, there's the incident angle right here. The ray of light comes in. That's my incident angle. Then I have my reflected angle, which is right here. So my incident angle and my reflected angle. And here's a question for you. What can you say about the relationship between these 2 angles? We'll give you some choices. And in fact, we'll see in Chapter 18, we have the law of reflection. And the law of reflection tells us that this angle, the incident angle, is equal to the reflected angle. So when the light comes in and hits the mirror, the angle that it comes in at is equal to the angle that it reflects out at. Okay? And if I change the angle and I make it shallower, we always have a match between those 2 angles. And that is our law of reflection. Now we're also going to use mirrors to make images. So I got a fresh piece of paper, and we'll do this. I'm going to take away the ray box. We don't need that right now. But now I'll explore this. I have a pencil right here, and the pencil, I can see an image of it in the mirror. So the pencil is actually right here, but there's an image pencil back here. And we can explore where the image is by doing this. I'll take a second identical pencil, and I'll put it behind the mirror, and I'll line it up so the 2 exactly overlap. And now I'm going to mark those positions by twirling the pencil. Then I'll mark the position of the mirror as I did before. And now I can characterize the position of the image this way. This distance we're going to call S. And this distance we'll call S prime. So S is the distance of the object to the mirror. S prime is the distance of the mirror to the image. And you can see these 2 distances are the same. So the pencil was here, that was the object placement, but the image of the pencil appears here, and it's the same distance behind the mirror as the pencil was in front of the mirror. And that's what we find for so-called plane mirrors, for so-called flat mirrors. Now we're going to draw some lines that show why this is true. We think about objects as emitting rays of light. So the pencil right here, rays of light come off it. The rays of light come off, and then they hit the mirror, and we know how they reflect. They reflect at an angle that's the same as the incident angle. So I have another ray that comes out, like so. I have many, and I could draw several rays that do this. Ray of light comes out, reflects at the same angle that it came in at. But if you look at the rays of light, they're traveling this way. If your eyes trace them backwards, so imagine you're looking from here. Your eyes trace the rays of light backward. Where they appear to come from is right here. So looking at the pencil with your eyes, you trace the rays of light back and see where they appear to come from. They appear to come from right here, though in fact, they actually came from right here. And we use this ray tracing idea to locate images. That's going to be a big theme in chapter 18. But we've looked at mirrors where the light reflects. But now we want to consider clear objects where the light can go in and it can pass through. And when that happens, it bends. That's something we'll talk about in the next segment.